The Future History of Energy and Transportation. Documenting the paradigm shift from the era of oil and internal combustion to the era of robotics. By Julian Cox. Narrated by the author with the aid of an artificial intelligence. Chapter 29. In concluding, there are very few genuinely vital classes of goods and services, all of which relate directly to the biological condition of mankind. The following is a possible summary of these: food, clean air and water, shelter, clothing, energy for light, heat, cooling, transport and the mechanical work of machines, waste disposal, human contact and communications. Some might add health and healing, others would argue that this is a subset of the above. At the margins of access to any one of these, otherwise healthy people experience acute poverty and all that poverty entails. However, with all of these vital goods and services affordable in high abundance, people experience increasing wealth and freedom to pursue higher interests, for example leisure, the arts, creativity, romance, spirituality, academia, exploration and the attainment of property. Jobs for the sake of it, repetitive maintenance and operator functions, falls somewhere between minimally wealth-producing and occupational therapy. Many of today's descendants of stable hands, muckrakers and blacksmiths of only 6 to 12 decades ago, now work as software engineers or on Wall Street, due to the delegation of mundane work to machines. Very few engaged in the solar energy industry are engaged in repetitive maintenance, and almost none per kilowatt hour of useful output is involved in operating solar panels, once installed. This divide between constructive labor, creating more assets, and repetitive maintenance, including the labor expended keeping an oil well flowing, is significant. 85% or more of the labor directed to oil and transportation serves the ground to exhaust pathway. Only the balance results in useful kinetic energy well to wheel. Aboard the RMS Titanic there were 173 stokers, firemen, in addition to numerous other laborers responsible for a total of 46,000 horsepower. About half the power at takeoff thrust and velocity of each of 4 GE 9115B engines aboard a passenger aircraft that requires just a captain, a co-pilot and possibly a flight engineer. None of whom is required to shovel, scrub or rake anything. When contemplating efficiency, be it labor, materials or energy efficiency, it is vital not to lose sight of the prize. Efficiency is the percentage of what we want as a percentage of what we put in. But what do we want? This is not as obvious or as easily agreed upon as it might first appear. In the case of oil, mainly we want kinetic energy, for acceleration, climbing elevations, for motion against wind resistance and water resistance in the case of boats, to transport people and to perform other useful work. Bottom line: we just want the useful work. It is worth paying attention to the definition of a proved oil reserve. Proved reserves are those quantities of petroleum which, by analysis of geological and engineering data, can be estimated with a high degree of confidence to be commercially recoverable from a given date forward, from known reservoirs and under current economic conditions. According to the World Factbook published online by the United States Central Intelligence Agency, the CIA, there are proved reserves of 1.665 trillion barrels of oil in the world, January 1, 2017. At $70 per barrel, that comes to $116.55 trillion of collateral for lending by the most simplistic valuation. Roughly a year of world GDP. At the current rate of world consumption, this is set to last for approximately 50 years. Once it becomes obvious that 25 of those 50 years is not required, without a clear and compelling value proposition available to replace $58.275 trillion of missing collateral at the root of the global economy, there will be trouble. Yet we now know what that value proposition is. Robotics. Building lots and lots of robots. A term herein described to include autonomous passenger vehicles as a first iteration, but also the entire gamut from miniature drone to container ship, and the humanoid robot in between. Also the smart grid, for the automated dispatch of electrical energy. Naturally, this makes a great deal of common sense, right up until the point of building machines that are productive in terms of work such as driving, traditionally referred to as labor. One of the reasons why this concept is apt to confuse, is seated in generally accepted accounting principles, or GAAP and its European counterpart, International Financial Reporting Standards, IFRS. These are standards that grew up in the world of the last industrial revolution, with various revisions since then. These are financial accounting standards that record investment in people on the side of the balance sheet marked loss, and record revenues less the sum of all wages and services rendered, as profits. These standards treat the exchange of cash for assets, like the purchase of a machine, as a matter of no effect on profits or losses, prior to the depreciation of that asset. Considering a thrust of this work is to explore an increase in prosperity for humanity as a whole, it may very well be helpful to draw a distinction between eliminating drivers and eliminating gainful employment. That is, freeing people's time and energies to meet their own needs and the needs of other people, customers, rather than meeting the needs of machines. For example, cars that can't drive. Something similar in principle to historically tying up large numbers of people to meet the needs of a system of washing clothes that can't wash, such as rubbing boards and mangles. A situation that was resolved for much of the world with the mass production of washing machines. As noted in a previous chapter, general improvements in standards of living tend to follow the inverse of the number of human servants required to live comfortably. Quite the reverse of any trending increase in an individual's ability from one generation to the next, to retain the services of other people, as the value of people multiplied by machines gains in value. This is an insight that management philosophies like Lean aim to deliver, by asking the question, is what I am doing adding directly to measurable customer value? Such systems are helpful and informative in pointing to the kinds of jobs people ought to be aiming to do. Thus something like Lean Gap and Lean IFRS to formally delineate between creative and value-additive human capital, engaged in the production of assets, versus human labor engaged in serving machines, maintenance for want of a better term, ought to be considered ordinary and not just an exception to the norm. Treating persons engaged in creating assets is important. Without something like Lean Gap and Lean IFRS in wider circulation, the inexplicability of value creation comes part and parcel with a gross risk of resource misallocation, sufficient to blindside and bankrupt whole industries, and this kind of thing is likely to become increasingly prevalent in the physical world of manufacturing with the rise of robotics. There is a considerable difference that delineates a labor force engaged in installing more solar panels and building more automated factories, versus labor engaged in mining more oil to maintain a constant output of barrels per day. The difference is one of compounding versus linear value output, and this truly matters to outcomes. Author's note. Long after first writing this, it was shocking to discover that Innovators Dilemma author, Clayton Christensen, had argued for exactly this for the latter part of his life. The most extraordinary technology disruption on the near horizon, measured in single-digit years, is not the cost watershed of electric vehicles relative to internal combustion vehicles. Neither is it a cost watershed in societal-wide energy efficiency or even the levelized cost of a solar array relative to power from coal or gas. It is to be found in the complete inversion of the customer from consumer to owner, as a supplier of miles and kilowatt hours. From employee selling his or her own labor, to supplementing it or replacing it entirely, by selling the labor and energy output of machines, in other words, robots. From tenant to landlord, the keys to widespread individual wealth and the lowering of the cost of vital services for all, are the autonomous electric vehicle, the storage battery and the solar array. The power to move mountains by thought alone, executed by a self-assemblage of machines is, but some few small and logical steps for mankind beyond this. In closing, it might be curious to mention that in 1926, the year before the launch of the Ford Model A, Nikola Tesla not only foresaw what can now be described as the Internet, once fully expressed in the form of global broadband in low Earth orbit, when he said, "When wireless is perfectly applied, the whole Earth will be converted into a huge brain," which in fact it is, and then too when he foresaw Apple FaceTime, Skype Mobile, Google Hangouts, Zoom and similar via an iPhone or Android mobile device, when he said we shall see and hear one another as perfectly as though we were face to face, despite intervening distances of thousands of miles, and the instruments through which we shall be able to do this will be amazingly simple compared with our present telephone. A man will be able to carry one in his vest pocket. Nikola Tesla also foresaw intelligent networked autonomy at the limits of what he termed telautomatics. Despite this author's most strident efforts to peer into the future, It is humbling to appreciate that at the very last, what was there to be seen, was essentially visible to Nikola Tesla 90 or so years ago. The future for which he worked, just as he saw it, remains his. Julian Cox.